Hello, students. Here we have day 10 of using inequality to solve problems. We're on page 24. We just went over an opening exercise. Inequalities are similar to equations, but instead of an equal sign, they have four different options. They are as follows. You have your greater than or equal to, less than, or less than or equal to. Now, in word problems, sometimes when you're doing your close reading, you're going to have to be able to interpret which of the four inequality symbols are going to be doing. So clearly, for greater than, you're going to be looking for words like is greater than, and for less than, it's going to be is less than. Right. And when you're looking at greater than or equal to, obviously, in word problems, they won't usually say greater than or equal to. You'll see words like at least, because greater than or equal to means it could be at least. So if I want to burn, using the fat burning or the calorie burning thing, if I want to burn 150 calories, I could burn 150 calories or I could burn more, right? At least, or no less than. And then for the less than or equal to, words that you'd be looking for would be at most, or no more than. This would be your calories. Like if you have a calorie limit of 2,500 calories, that's the most that you can eat in one day. So, example number 1: write an inequality for each and solve. All right, so we're going to write inequalities for each one of these and solve, and I'm going to add the graphing piece in here because I want to kind of review that a little bit. So, first thing we're going to do is I'm going to let you write these inequalities yourself and work through these. I'm just going to change these. Sum of two numbers, 2 times the number, and take out the negative there. All right, take out the negative on this one, and take out the negative on that one. All right. So you can go ahead and pause the video and work through this. Try to write these inequalities out. Go ahead and solve them and graph them. Hitting pause now. All right, and we are back, and you can see our inequalities are solved and graphed. I said that n was going to equal the number as my let statement, and I just used n for all of these. You see a lot of similarities. This one here I wanted to take a look at because sometimes when you get decimals, if you're thinking of whole numbers and it has to be no more than 16, right, we're going to look at that in another problem. But you can just pause this and check these over, and you can obviously ask me for questions as you're working through. All right, moving on to example number 2, the real word problems, I guess. Evaluating inequalities, finding a solution. All right, so we're going to do our close reading. So remember, I do my close reading and I annotate as I go. Connor went to the county fair with $22.50 in his pocket. All right, so I'm going to highlight that. He bought a hot dog and a drink for $3.75, and then he wanted to spend the rest of his money on ride tickets, which were $1.25 each. We're going to write an inequality to represent the total spent, where R is the number of tickets that are purchased. So I give you the letter. All right, so here's how this works. In an inequality, Connor went to the county fair, $22.50 in his pocket. So I'm going to write that down, $22.50. All right, now here's the deal. When you have this amount of money, you can spend no more than $22.50. So you could spend $22.50, which is the equal, or you'd have to spend less than $22.50. You can't spend more money than what you actually have. Right? Now the rest of this is that he bought a hot dog and a drink for $3.75. So that's the extra amount, like in the equations that we were writing that were very similar to these. And the rides are $1.25 each. So $1.25 per ride would be $1.25 R. Right? So now we're going to solve this inequality just like we would solve the equation. So we actually take $22.50 and we're going to subtract 3.75. And you can use calculators here. So I get 1.25 R is at least or at most $18.75. So after you take the $3.75 off that he paid for the hot dog and a drink, he had $18.75. So now I take $18.75 and divide it by 1.25, and I get R has to be less than or equal to 15. Which means that he can go on at most 15 rides. That's the number of rides. And this number came out nice. So, all right, now Connor wants to use this inequality to determine whether he can purchase 10 tickets. Well, 10 is less than 15, so yes, he can purchase 10 tickets. It said use the substitution to show whether or not he will have enough money. Well, that was doing where you take, 125 per ride times 10 rides, and then you add the 375 to show that it's under the 2250, or at most the 2250. So here you get 1250 plus 375, and you get $16.25. So, but you already knew that by looking at the inequality. Rides have to be less than or equal to 15, and because 10 is less than 15, it is true. All right. The next example. Sometimes this is going to bring up an interesting case, and I think most of you are going to understand this, just going based off of previous knowledge. Okay, at most, there's the word right there. He can spend $50 on sandwiches and chips for a picnic. He already bought chips for $6, and he'll buy sandwiches that are $4.50 each. Write and solve. This is very important, because if it says write and solve, you must write an inequality to get full credit. All right, so we're going to write an inequality. So at most, he can spend $50. The at most means less than or equal to. He can spend $50, or he can spend less than $50. He bought chips for $6 already, so that $6 is going to get added in, and it's $4.50 per sandwich. So we're going to let, I forgot to make the let statement, let S equal sandwich. Okay, so 4.5S. Okay, so there's my inequality. So we're going to solve. We'll subtract 6 from both sides. You get 4.5 sandwiches less than or equal to 44. And here's where a calculator comes into play. My calculator is a little bit different than the ones you're used to, but it does operate mostly in the same. So take 44 divided by 4.5, and I get sandwiches has to be less than or equal to 9.7. It looks like it repeats. All right, now, to answer the question, how many sandwiches can he buy? So one of the things we'll talk about is how this symbol here determines that. Okay? Could he buy 10 sandwiches? Or can he buy 9? That's the million-dollar question. And because it's less than, sandwiches has to be less than. And you won't buy 9.7 sandwiches. You won't buy 9.5 sandwiches. The most you could buy would be 9. It's not a rounding issue. Okay, because I know some of you may be inclined to round that up to 10. But the problem is that inequality fixes that. All right. Now, on the other end of that, this is off to the side. Let's say you ended up with an inequality where R could be at least, let's say 2.4. Has to be at least 2.4, and it's a situation where it has to be. Once again, it's not a rounding issue. In order to be greater than 2.4, the next number would have to be 3. You'd have to use 3. Right? And that happens from time to time in these inequalities. So, all right, from here on out, what you're working on is you have the exercises. And it looks like you got 1, 2, 3, 4. And there's a challenging one there for you to work on. So, right. Stay focused, work hard.